Hello, today we're going to be checking out a demo for a game called Sokobond Express. If you've seen my channel, I have played Sokobond before. Fairly briefly, I've played it. I've played the regular Sokobond, which is basically about pushing atoms to make molecules. Sokobond Express is a bit like that, but it also has elements of Cosmic Express, which is about building a train track. It's about building a train track such that the moving atom can so-called collect all the other molecules and make a final molecule. So what just happened there was the hydrogen atom moved along a track. It bonded with the other hydrogen atom, making a hydrogen molecule, a H2 molecule. So humans were literally made of stardust because most chemical elements were created in the dying stars in the early universe. Alright, cool. Oh, wow. Okay, yeah, if you remember, in Cosmic Express, the map kind of branches out in like some constellation pattern. Here it's branching out in some hexagonal directions. Not hexagonal, but it will form hexagons, I would guess. It will form hexagons, which is, key to organic chemistry. So here's our beginning. You have to draw a kind of path. Can I erase? How do I erase? Oh, okay. R just resets it. You have to hold it. Wow. Okay. Let's see if there are any settings. Oh, we have hints. Ooh. Alright. Interface. We can switch on dark mode. Oh yeah, this is way better, I think. So settings is just for the weird. No controls yet. Alright, fair enough. So I click R and hold to restart. So what do we want to make here? We have a nitrogen that is moving over. What happens if I did this? It would break because the oxygen is trying to move forward, but that would hit the hydrogen atom. So tab is to speed up and space is to stop. Z is to undo. Alright, Z undoes it. Oh, and I just click normally to undo. Alright, preview. What does preview mean? Means something like this? Oh, it means the atom that will be formed. This preview shows what atom will be formed. So if I did this, I will successfully make this HNO atom, which is good. Yes, okay. So, contrary to popular belief, having plants in your home doesn't actually do anything to purify the air. Interesting. What is this element? What is this molecule here? It is... actually, I don't know what name this one is, but I think it's chemically correct. Right. Anyway, next. I can't move around the map so far, I don't think. Yeah, I can't. Let's go to level 3. Now this nitrogen must touch all 4 of these hydrogen... all 3. Did I say 4? I meant 3 hydrogen atoms. So it has to touch one first. It can't go here because, well, obviously it gets stuck. So even though it does make the ammonia, I think it's called ammonia. Even though it does make ammonia, it would get stuck and it wouldn't be able to move. We can't continue to track. So it will have to find it some other way. So I think we can go around. Maybe go around the back. No. What about like this? Okay. And then we only need something on the side, which can be accomplished when N is here. So I think this works. And tab speeds it up. Cool. Alright, there's our ammonium molecule. A lot of everyday materials like plastics are made from fossil fuels, so we have to learn to live without them in the future. That's true. Alright, last visited. Oh, okay, these aren't like the names. I thought these were the names of the levels. No, this is unlocked. These are all unlocked. And then this is the one that I last visited. Then we have some question marks here. Alright, let's get level 4 in alpha. We need to make C connected to 4 hydrogen. If you think about it chemically speaking, each orbiting circle here is an electron, and 2 electrons in 2 separate atoms can sort of bond with each other. They kind of the two will how do I say this? Okay, I don't want to give a chemistry lesson right now, but essentially what is going on is that this H sort of shares its electron with a C, and all of them have to bond to the C that way. So each of them share an electron with the C. So C will gain, this carbon will gain 4 electrons, while each hydrogen will gain 1 electron from the carbon each. And that is correct because, you know, according to chemistry, the octet rule, whatever it is, each carbon atom must have 8 electrons around it for it to be stable, I think. Stable, I don't actually remember what it's like. I'll have to look through my notes. Yeah, okay. Anyways, we want to make methane, which is C and 4 hydrogens, so CH4. Now this by default already bonds to a H here, which forms this kind of shape. So I guess we would have to move like this. This is okay so far. I can move around, I think. When it goes here, it will bond with this H on the top. So now this is going to have to do this. And we're going to have to go around to make sure this H doesn't collide with this one and walk like that. So I think this is correct. Yes, okay. I didn't notice, but the H actually moved out of the available area, but that was fine apparently, because there are no tracks. The tracks cannot exit out of here. Diamonds have more in common with pencils than other gemstones because, like graphite, they are only made of carbon atoms. Yeah, that's true. Diamond is made of pure carbon. Pencils have like graphite in them. The pencil lead is made of graphite, which is also carbon. It just kind of depends on how hard you compress the carbon and in what structure the carbon atoms arrange themselves. Anyways, level 5. C, H, O, and H. Ooh, I don't know what this forms. This O has to... Alright, it's just... Yeah, alright, this O forms two... it forms a double bond, as you can see, because the two electrons from oxygen bond with 2 electrons from carbon. So I think actually what we want to do is get hydrogen from the top, move it, so now we can get oxygen like that, move again, so we can get hydrogen like this. And I think if we move here, that'll be wrong because this oxygen would collide with this hydrogen, so we have to do something like this and then go around like that, and we don't have to worry about atoms being outside of the available area. Yeah, it's absolutely fine. The green and slimy stuff you find in ponds, lakes, and rivers is algae, and it is being used to create environmentally textile dyes. That's cool. Alright, level 6. Now again, when I form methane, CH4, I can do something like this. Alright, so I don't have to hit a hydrogen atom first, but maybe I want to. So I have to make sure that the carbon gets on all sides. So if I do something like this, then I maybe have to do something like this, and then something like this, and then something on top. No, but yeah, this would clash, which is bad. Alright, then what if I go like this? This is bad. If I went something like this, right, then I could do something like this. Yes, so this one connects, the H connects on the left of the carbon. Here the H connects on the right, here. Then here the H connects on the bottom of the carbon, and then here the H connects to the top, so everything is touched, which I think works. Yes, okay, nice. The first person to discover carbon dioxide was a greenhouse gas was a woman, Eunice Newton Foote, but John Tyndall usually gets the credit. No idea why. It happens a lot in science. I'm not gonna say anything about that. Alright, new world, beta. We got a new line, nitrogen. I don't think there's anything different about it though. Yeah, I don't think there's anything different about it yet. Maybe there will be something different. But here, C, N, and H it makes cyanide. It will have to have the H bond with the carbon and then the hydrogen. Yes, so the carbon has to bond with the nitrogen first, making a triple bond. So as you can see, something like this. So a triple bond, and then the carbon bonds with the hydrogen. So if I did something like this, then here there'll be a bonding because carbon will be here, nitrogen is here, carbon is here, and then the carbon would bond with this hydrogen here, its last atom, and then we could go in like this. So now we are working with the fact that the train, so-called, doesn't have all of the bonds. We think that the dinosaurs died a fiery death because sediment samples from the time contain lots of iridium in elements commonly found in asteroids. Oh, that's cool. Alright, number 2. So now oxygen is our train. How do I want to make this? I'm thinking of eventually setting up like a paint screen so that I can just draw and see what the element would look like. Maybe I should do that right now, right? If I can do a paint. So I'm gonna open up paint. Cool. Alright, that paint works. I don't know if setting it up right now is good. But let's open a display capture which we shall call paint. Oh my, okay. So this is captures. Is it wrong? It's wrong. Hold on. This is bad. I'm so sorry. What is this? Is it window? It's a window capture, not a display capture. Alright, this is paint. There you have paint. Alright, no idea why the top is empty, but sure. Why is this section empty? Weird, but can I draw? Does it show up? It does, alright. So as long as you can see the screen and you can see paint, I think that's good enough. I don't want to make it any smaller than it needs to be, so I think this is good. Alright, so let's see what element this can make, right? I'm guessing that it's the nitrogen and nitrogen which bond together. Should I use my pen for this? I have a pen. So nitrogen and nitrogen bond together, and then there's an oxygen on two sides. And why is this so? Because symmetrically, symmetrically, the oxygen would have a double bond with nitrogen, and then each nitrogen will have one left bond with each other. So this is what it looks like, I think. And we're gonna have to build that with an oxygen. So definitely an oxygen has to first bond with a nitrogen, which I think we're gonna have to do like this. Then oxygen's on top. Does this work? Yes, technically, because the nitrogen bonds with nitrogen. I think that's good because yes, we got a nitrogen bonding with a nitrogen here, as you can see. And then as we go down, we have the oxygen, so we have to go up like this. Yes, so the oxygen bonds with the nitrogen like that, and then we just finish. And it should be right. There we go. Okay. So it's different from my drawing. My drawing is a straight line, but it's basically the same thing. You can sort of move the atom around. You can move the oxygen atom, like shift it around the nitrogen atom to give it basically any orientation, as long as the bonds and the number of bonds are correct. So salt isn't only good for making our food taste better, it also reduces the freezing point of water. This is why we spread it on roads in winter. Yeah. Chemistry. Wow, this is really chemistry. Okay, gamma. That's fine. We'll look at beta first. We have a hydrogen that's outside, so we have to bring it in from the side. I think that might be interesting. Right now we have two oxygens, a nitrogen and a hydrogen. Again, not very sure what this forms, but we can make that. So it's, do do I write it down on the side? Oxygen, oxygen, nitrogen, and hydrogen. If we had the nitrogen and oxygen first form a double bond, then I think this nitrogen can form a single bond with another oxygen, which then forms a single bond with hydrogen. So our molecule will look something like this. Yeah, our molecule will look something like this. So how do we start that? We have an oxygen here which has to bond with nitrogen first. It cannot bond with itself because that breaks. So first it bonds with nitrogen. Now it has nitrogen below it. Oh, but that's not good because... Yeah, because how do we bond with this nitrogen? No, we can't have this oxygen be on top. Let's have the nitrogen like that. No. What about having it something like this? So this has the nitrogen here, which will make... What? Oh. What the... Alright. So here we have something like this. But this is bad though, because we know the oxygen has to bond here. But if I brought this back in, it would never bond with this H because the oxygen is on like this column right now. So I can reset. Alright, let's restart. How do I want to do this then? Do I want to bond from the bottom? Then something like this. Ah, yes. If I went up, it would bond with oxygen on the left. But if I turned early, then the nitrogen will be right below it, forcing the oxygen to bond from the top. And that's good because now I can put it here. Or is it here? Yes, the oxygen is 2 above. So now the oxygen will be here, which bonds with the hydrogen, and we can finish it like that. And it should form something that looks basically the same thing as what I've drawn here. Alright. There we go. The reddish color of Mars comes from the same molecules as rust, and that's actually iron oxide, making the red planet not so alien in comparison to the old bike in your garden. Nice. Alright. Now we have a much bigger square. Ooh, 2 carbon, so this is no longer methane. But I think this is not that difficult. I will still draw the molecule that we need to make though, for simplicity's sake. It is a carbon with a double bond to another carbon and 2 hydrogens on each side. This is called ethane. I feel like I'm giving a chemistry lesson right now. This is called ethane. It's a double bond between carbon. It's basically this is something called a hydrocarbon because it's only made of hydrogen and carbon. It's called ethane because ethene. It's called ethene. The ene suffix at the back is referring to the fact that there's a double bond between carbons here, and the eth prefix in the front is referring to the fact that there are only 2 carbons. So ethene. This is ethene. Now how do I do that though? We start with hydrogen here, which must obviously bond to carbon first. But the carbon must also bond with another carbon. So if I did something like this, the carbon can bond like... No, the carbon will be here. So I can do this, making a carbon, alright? This forces the carbon to bond with another one. But this one, oh, well, I can collect this from the bottom of the carbon here. So I can do something like this. Wait, where's the carbon? No, the carbon's on top. So I think I can do something... Oh, but this... No, this doesn't work. Right. I need this hydrogen to be on the side. This is bad because... Is this bad? No! Oh! Wait. The hydrogen... Well, we're talking about... We are... this train is in the perspective of the hydrogen right now. Right, so here this is the hydrogen and the 3 molecules on the side are here, so I can move up, and then we have a T shape here which barely dodges everything. Then we can move everything and join up like this to make something that looks a bit like hydrogen, but something that looks a bit like what I've drawn here, but with one of the hydrogen moved a bit. Alright, the thing about this is that I don't know if it's really that It kind of looks like I'm making all these solutions by accidentally discovering them. I don't know if that's bad. It might be bad. Carbon dioxide is infamous for causing climate change, but mosquitoes also detect it in our breath, which is how they find and annoy us. I didn't know that. I know that humans have some scent that mosquitoes and bees can track. They breathe out like a scent that mosquitoes can track. But I didn't know it was carbon dioxide. So I guess we're all learning something here. Level 5. Oh my gosh. This nitrogen hydrogen complex, is that what it's called? A molecule made of nitrogen and hydrogen. Again, I will draw what this molecule looks like. I already have a decent idea. It's N2H6. I don't know what it's called though. It's a bit like the ethene that we drew just now. It's essentially the same thing actually, because in this kind of puzzle it doesn't really matter how many bonds are between each. But this is what it looks like. It's basically the same thing as our ethene. So we're first going to want to have... So we can't do this because this hydrogen automatically gets... if I collect this hydrogen, I automatically collect this hydrogen as well. Maybe that's good, maybe that's not good. But maybe I want to do something like this instead. Oh, no. This forms a double bond with this nitrogen, which is bad. I do need to collect 2 hydrogens first. Can I do this? This nitrogen needs something on the side, which I can do. And it needs something on the other side, which I can do, like... Well, we're looking at the nitrogen from the top here. We're looking at the nitrogen from one space above this. Good, okay, this is fine. And then something like this. No. Like this. So... a bit weird. I don't know if that's good or not. Alright, well, what happens if we just collect these 2 first? There's no way to get this then. Yeah, there's no way to collect that, so we can't do that. Let's see if we can do something like this. Alright. Now this might seem like with this hydrogen here it collides into this hydrogen, but no, it's already collected, so we don't need to worry about that. And I think that is a solution. Again, accidentally found it, so I don't know if that's good or not. But there we go. Fruits and vegetables release ethylene, oh that's ethylene, okay, to become ripe. So storing everything together can cause more sensitive fresh produce to spoil faster. Alright, now that's beta world complete. Let's look at gamma. Now this is again NH and O, which we've done before. No, nothing new so far. But here we're looking at something like this, and then something like this. Is that right? Oh, you cannot have... You cannot... Wait, what? Has it never been like this? You cannot have... you cannot end the product with something outside the playing area. That's weird. But I guess reasonable. Let's do something like this then, and then this, which should work. Oh, I didn't realize that we've never actually been in that situation before. Helium was one of the first things to exist in the universe. Humans use it to blow up balloons and give themselves a high-pitched voice. Yes. Alright, level 2. Now we want to make methane as shown here, so we must collect this carbon first. I'm pretty sure we must. Ooh, and it's very interesting because... Yes, alright, this H has to reach here, right? And when it does, nothing can be outside. So essentially our molecule must look like this, which means that this H must be on the right side of the carbon. So something like this. Yeah, what? Where is the carbon right now? Carbon's right here, which doesn't work. Okay, I guess this works. Because here the carbon will be here, which connects to this hydrogen, and then when I move, the carbon will be here, connecting to this hydrogen. Or should I say bonding? I don't know. It's more chemically accurate to say bonding. Electric stoves might be terribly slow at boiling water, but gas stoves are worse for our health as they produce more toxic chemical pollutants. Alright, 3 oxygens and 1 hydrogen. This is a little bit like regular water, but with a lot more oxygen in the middle. I can draw it out for you. We have H here, oxygen, 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 and then hydrogen. This is our molecule. I don't know what it's called, but regular water is just H2O, which kind of looks like this. This is regular water. So this appears to be some extended version of it. But essentially, when we're here, nothing can be outside. I guess there's an issue about that. So we can't start with it connecting to oxygen because then it forms the immediate double bond, which, as we've seen in our product here, cannot happen. So it must form a single bond with oxygen first, and then I guess form a single bond with oxygen here. Then it needs to form a single bond with an oxygen here, and then form a bond. Where is it? Here. Yes. But when this oxygen is here, things will be outside, so that's wrong. Pretty sure you collect this first. You collect it from the other side, and then do something like this. Yeah, so you can make the L shape. No, this doesn't work. So I have to go around like this. Next, I have to put something like this. I think that works. Yep. And then I guess I go around the long way, and then like this, which should be fine. Yeah, it should be fine. Here we have the oxygen, then the other oxygen would be here. A very weird molecule, actually. So the first soaps ever were made by the first soaps ever made were created by mixing animal fat with wood ash. Thankfully, we've moved on from this prototype. Yes, current soaps use fats now. It uses long hydrocarbon tails, as well as I think polar heads, and then each of them separates water and oil, I think, which makes it so that soaps can remove oil from your hand a lot more easily. Alright, new molecule, I think. This looks like... Alright, I think I know what this looks like. Let me draw it out. We start off with the nitrogen. And then, what does it look like? It's 3 hydrogens and 1 more oxygen. We connect this hydrogen to an oxygen, which then connects to another hydrogen, and then the nitrogen connects to 2 more hydrogens. If you look at it, basically every nitrogen must connect to must have 3 bonds around it. Oxygen must have 2 bonds. Yeah, that's the basis of most of these molecules. Most of these carbon, oxygen, hydrogen, nitrogen, most of the time it happens like this. Most of the time. There are a couple exceptions, you know, with dative bonds and covalent and ionic bonds, but we probably won't look at that for a bit. So, we need hydrogen first to bond with oxygen or nitrogen, but I don't think we can bond with nitrogen yet because, you know, we could do something like this. Maybe. But this is obviously wrong. Yeah, okay. I should stop. So hydrogen first bonds with oxygen. We know this hydrogen has to be in the corner though. So could we make it so that... Yeah, so nothing can be on the left or the bottom of the hydrogen. So this is bad firstly because something is already on the left of it. So I guess we have to start with something above it. the oxygen must now bond to nitrogen, which is whoa, this is not good. What does this do? It doesn't bond with anything. Oh wow. Alright. Because normally here it would bond with hydrogen, here it would bond with oxygen, right? But it bonds with neither when it passes through here. Well, I guess similar to like regular Cosmic Express, if you have two things on opposite sides, none of them get on the train because like bump into each other. Fair enough. Oh, this is fine. Yeah, this is fine. This is fine. This is bad. This is bad. Nothing can be on the left, so we have to go down and collect the hydrogen from here. Wait, but we can't do that. We can't collect hydrogen. Yeah, it is bad. So we have to go around the back like this to make sure that our oxygen first bonds to nitrogen like so. And then the nitrogen moves left to bond with this. And then moves left again and down to bond with this. Which should be correct. Moves left and then down and left and down. Alright. Dance floors are a good place to let loose, but they could also generate energy from all the stomping around if they're made with special materials. Oh, okay. Cool. Delta. Alright, let's get level 5 for Gamma. We got 3 empties here, and a final one here. Ooh, interesting. This oxygen must therefore have something empty here. A lot of different molecules now. I think this calls for a new molecule to be drawn. I've basically been drawing a new molecule every single time anyways. What is this? Carbon and nitrogen probably go together. Probably. And then I guess oxygen, maybe something like this. Is this good? I think I've seen something like this before, some like amine structure. I think this is right. I don't know, let's draw it better. So we have a carbon here, bonded to a nitrogen. This nitrogen is bonded to a... No! Yeah. It's bonded to nitrogen, which is bad, because this nitrogen, I guess, is bonded to an oxygen like this. That makes sense, right? Yeah, okay. Now this is bonded to... this is bad. Wait, what? How does this work? Maybe this carbon is bonded to an oxygen here. No, it must be bonded to a nitrogen. Yeah, okay, and then maybe we have an oxygen here which is bonded to hydrogen? Oh, like this. Oh, wow, this works, doesn't it? Alright. Okay. Trial and error. Let me show you a little something. So, C connects with H. This is much better, isn't it? I realized that I should have just zoomed in. Maybe it's not good for you guys. It's pretty small on the main screen. But this is better for me, so. I'm trying to draw as nicely as possible. But this is the final product that we kind of want to make. Carbon with a triple bond to nitrogen and then one bond to oxygen. Oxygen bonds to another oxygen which bonds to hydrogen. This COOH I think has a name. Oh no, it doesn't. This COOH is fake. It's not a real COOH that we see in chemistry. A real COOH, a real carboxylic acid doesn't look like this. But I guess it's an actual element that we could create. This oxygen first therefore must have a single bond to hydrogen first before it can make more single bonds. Otherwise it will just form a double bond with this oxygen. So I guess we must do something like this. No, we can't do that, can we? No, because hydrogen must be under it. What? Alright. Wait. this is wrong, then I mean it's correct, but if this oxygen can't bond with hydrogen in any way, then surely this is wrong. Yeah, this can't be right, can it? Is there another way to make this? I guess knowing that now oxygen must have a double bond with something. Does it have to have a double bond with carbon? Maybe this? This is another way you could do it. But then how does this oxygen go with the carbon if it's so far away? You need to do something like this first. But that's bad. Okay, hold on. I can do something like this though, which does sort of look like it would help. We want carbon to be under it, definitely. And then next we want the carbon... Oh wait, yes, double bond with carbon. And the carbon bonds with nitrogen, which we can do like this. Nitrogen bonds with oxygen. And then we can... this. Is that good? Yeah. Okay, that barely works. This, if the oxygen was here, then the second oxygen will be here, which bonds with this hydrogen. And this U shape over here just barely makes it. So this oxygen here would have the U shape kind of hugging itself against this block. Or this void. Alright, there we go. Wow, that's really satisfying, yeah. Scratching an itch feels so satisfying as it prompts the brain to release serotonin, which can and in fact end up making the itch worse. That's a bit concerning. But hey, this is the first time my molecule actually looks pretty similar to the intended solution. Anyway, 6, gamma 6. Final level, we got some oxygens in the void. Now this nitrogen, oh, it already bonds, right? Yeah, okay. So it starts off by already bonding to this oxygen here. Now there can be nothing above and to the left of this nitrogen. So what does this atom look like? What does this atom look like? We already know that this nitrogen has double bonds to oxygen like this. There can be nothing above and to the left of it, so it must have its third bond acting downwards to another oxygen. Another oxygen seems plausible. I guess this then continues with yet another oxygen. Right? Which then finally has... No, but this doesn't work because then the final end needs a triple bond. Wow, okay. So maybe this actually bonds to nitrogen. Yeah, which then has a double bond to oxygen. Alright, this makes more sense. It's like it's screaming no towards me, which I am inclined to not comment about. But this no molecule. I don't know why I keep saying it like that. Alright, so that's what we're gonna want it to look like. This nitrogen has to therefore bond to an oxygen first, which I guess has to look something like this. This oxygen then bonds to nitrogen like this, which is fine. And then this oxygen has to be below, I think. So something like this. No, this would break. Okay, that's not good. Is that bad? Could we bond it in some other way? This is bad. Because oxygen cannot do that. It has to be below. Can I do this first? Does this just work? It doesn't look like it works though. technically it works because it does everything, but there's now 2 empty here. Yep, okay, it doesn't work. Okay. At least this game is chemically accurate. This can't happen. Alright, fair enough. So we do have to bond to this nitrogen first. Is there any other way? This breaks. Alright. What if nitrogen bonded to nitrogen first? Wait, but that doesn't work because then it needs a double bond with something. Right? It needs something like this. Which we can't do because then this, if it bonded to oxygen, then there's no bonds you can make after that. I'm pretty sure that this just has to be the case. I'm pretty sure what I've drawn here is the only way to make it work. Maybe it's not though. I'm not gonna try it out with the oxygen just yet. Fine, maybe I will. But no, because yeah, this bonds here and it creates a complete molecule which cannot bond with this other oxygen. This doesn't work because at the end point there would be an oxygen up here. This breaks. Oh, I could bond to this one first, couldn't I? Yeah, that's true. I could bond to like this one first. Oh, but this doesn't work. Alright, what if I did something like this? No? Alright, okay, fair enough. Oh, what if I went around then? And went from the top. There, wait, yeah, this works. There is this little shape here, which does fit this. Alright, there we go. So I got it right at the beginning, I got it right. Okay, got this double no here. Scientists have engineered plants which can suck up pollutants from contaminated soils, making them suitable for life to thrive there again. Yes, but have you thought about the plants that suck up the pollutants themselves? I don't know if those suffer at all or anything. Alright, that's the gamma section complete. Again, I can't move the map. There's something up there, but I can't move it to like put it in the center. So I guess we have to continue with delta. Again, looks pretty normal. No new concepts, except this hydrogen and this oxygen here. Yeah, wait, this oxygen has an extra electron. This is an electron is negative. Its charge is negative. So a proton is positive when an electron is negative. A neutron has a neutral charge of 0. So this oxygen now has a negative charge, making it a cation, is an O minus. What happens if I bond it to this? That works. But this hydrogen... What does that hydrogen do? What is this black thing? Is this just a regular electron? Doesn't look like it. Is it a hole? Is this a positive now? Because if it's lacking an electron that it's supposed to have, then its charge is, you know, 1 greater, has less electrons, so it's less negative, which makes it more positive. So now this is positive, which makes this a cation, a hydrogen cation. This is an oxygen anion. And so putting them together, you get a positive charge plus a negative charge, which in total cancels out. And then this oxygen would still be normal because it still has 2 of its extra electrons that are not fit together, which can then bond with this other oxygen here. So the minus here and this plus here connect in such a way that forms, I think, what appears to be a sorry, what was the term again? An ionic bond. It's an ionic bond. Whereas previously we have made covalent bonds when 2 atoms sort of share electrons with each other to make a single, bond. This hydrogen just takes the electron away from this, it just takes it for himself, which makes it a covalent, an ionic bond. What happens if I did something like this? I think this works. So this oxygen first bonds with this oxygen with its two regular electrons. It actually doesn't really matter because they're all the same. All the electrons are the same. And then the third electron would be given to this hydrogen here. There we go. Oh, I am stupid. That's even worse than... well, okay, what if I just did it the opposite direction? No, again it doesn't work because this hydrogen is in the wrong side. Can I do it like this and then like this? Yes, I can. Oh, whoa. Okay. So, I guess this hydrogen now gets its electron, which makes it its own hydrogen. And then this oxygen, yeah, alright, so a quote-unquote covalent bond, I guess, is separated in the final screen. Not real chemistry though, they bond really tightly together in an ionic bond. Ionic bonds are really strong as well. When drugs are broken down by the human body, smaller molecules called metabolites, I think, metabolites, are produced which can be detected for up to 90 days in our hair. Oh, okay. Fair enough. Let's look at 2, delta. So, COOH. This H must connect to this oxygen, I guess. So yeah, it doesn't connect to this one because it must connect to the one that is negative, I would assume. To be fully fair, that's not how real chemistry works. If there's an electron, there's an electron. But I guess in-game, I guess this must be forced. So firstly, bonds like that. I don't know what to do with this though. I think that's better. Yeah, that's way better. Because the carbon would be what? Here? Would it be here? Yeah, the carbon would be here. It would make this shape. And this carbon would bond with this oxygen. And then the hydrogen itself. So we make CO2, which is carbon dioxide, and hydrogen atom, I guess. We think of baking soda volcano. Well, we think of a baking soda volcano when we hear the phrase chemical reaction, but the human body is basically just loads of them happening simultaneously. That's true. Chemical reactions are everywhere. Now we got this oxygen now has its special missing electron here, which it must collect from this. So what happens? Okay, I guess we can't do that yet. I guess this hydrogen must first bond to this carbon using its regular electron. What happens here? Oh, maybe this is fine. Yeah. This doesn't work obviously because there are 3 on the outside. This works. Does this also work? No, it doesn't work. The reason why is because at this point, our atom will look like this, and then if we go up, okay, fair enough. So we go around it a long way, which should work. Again, I'm not really thinking about this at all. I'm just moving the track around until I get something that works. This is more like just a chemistry lesson, I guess. So now we make, this is an OH, wow. Alright, this OH is, a hydroxide ion. This is a hydrogen atom. I don't know what's up with this dotted line here. I don't know what that means specifically, but this is meant to be an ion. This is meant to have like extra. Here, there should be an extra electron here. Anyways, broken screens aren't the only problem with mobile phones. We are eventually going to run out of the chemical elements we need to make them. Yeah, if you look this up, mobile phones have like radioactive elements in them in very tiny amounts. Finished? I didn't finish this. Wait, did I? What is this? Alright, well I'm not gonna look at that first. Let's finish delta first and see if we can solve it. This is nitrogen with its special missing electron, which needs to bond to this one. So, if this bonds here and then here, let's do this instead. what happens here is that... Ah, yeah, okay, now they each have one electron, which is bad because the oxygen cannot bond to both of them. It's not triangular, in general it's rectangular. So I guess even if in some cases you could form like cyclic chains, circular chains, it's not possible here because there's only 3. So we're gonna have to restart here. What if we bonded from the top? And then we had the second one. No, wait, no, this is the same thing. We're making the same. It's not about geometry here, it's just about how nitrogen is bonding. So if nitrogen happens to bond like this first, what is the thing here? It bonds with this one to make nitrogen here, and then it moves over, makes one here. This is fine. No, this is not fine. Hold on, what? Oh, I see. This oxygen, right? If it bonds to... What is going on? What is this? Oh, it already connects to that H, that's why. Alright. No, that's not cool. That's why I was wondering there was no bond with this, because it's already bonded. What that means is that I think this nitrogen must first bond with this oxygen then. Yeah, something like this. I think this is fine. No, this is not fine. The oxygen has to be somewhere else. We'll put the oxygen below us then. Yeah, this should work. I'm sort of grasping what this is supposed to be about. So now we have an NO molecule. I think that's a thing, I don't remember. It requires like dative bonds and whatnot though. This is a hydrogen molecule, regular one. Recreational drugs leave trace chemicals in human waste, so scientists can see which cities are taking which drugs and when by testing wastewater. I've never thought about it that way, but sure. Now 5 delta 5. This oxygen... Alright, this negative thing is really messing with me. This hydrogen bonds with this hydrogen. And then these bond regularly, so... What it kind of looks like, I think if I can draw, is... Firstly, a hydrogen must give its electron to this. Alright, technically, in terms of chemistry, this is wrong. In chemistry, this is a dative bond where one molecule gives both of its molecules to the other one to form a covalent bond, like a regular bond. But in this game, I'm just gonna take it as this hydrogen gives its... one hydrogen will give its special... This hydrogen gives its special electron to this hydrogen, right? And then there is one more hydrogen, so that works as per normal, which we can use to form a regular molecule like this. So this is what our final molecule will look like, with this forming here. So I guess we can think about it like that. This oxygen must therefore bond with a hydrogen first, and to another hydrogen as well. There can be nothing below the there can be nothing below the oxygen though, so we can't do that. We can do this though. And then this is bad. This is okay, because our molecule will look like this. Now this oxygen must hook up like this. That's fine. Oh, this is bad. What? Is this okay? This is okay. This is okay. Here we have the special electron on the left of the oxygen. So moving here, the special electron will be here, which will bond with this special electron. I'm just gonna call it a special electron, to be fully honest. I don't really want to bother about what the actual, term is about. But there we go. H and a HOH. The UK Navy started plating ships in copper to stop shipworms destroying the hull, but this actually ended up making the ships sail faster. Alright, a win-win situation, I would say. Now, Delta 6. Why would the ship sail faster though? Does it have something to do with like conducting heat? I'm guessing so? Or maybe some chemical reaction with the minerals in the water or something, I don't know. I would have to say it's probably something to do with conducting heat though, because copper conducts heat pretty well. It also conducts electricity pretty well, so I don't know if that's involved. Anyway, here we have... Oh, we have 2 special electrons. Cool. So can I draw this out? We need, firstly, an oxygen to give 1 electron to... I think an oxygen, right? Yes, and then the next one, we also have a hydrogen that gives 1 to its oxygen. Now these oxygens each have 1 more, so they can bond to 1 thing each, I guess. Alright, so I think we will do something like this, and then they can bond to each other. And then this oxygen has 2 more, which it can then use to bond with 2 hydrogens like this. So this is our first cyclic, or cyclic, whatever you call it. This is our first cyclic molecule. Here we can see there are 4 bonds here that are purposely made in a circle fashion. I don't know if this is possible, but this looks correct so far. And we will see. So firstly, we take this oxygen. It's not forced, but we will. Oh, this oxygen already bonds with this hydrogen. Wait, that is not good. Wait, what? Alright, so that's not how it works then. So this oxygen will bond to another oxygen that is already bonded to hydrogen. And this hydrogen is complete. Now this oxygen, therefore, is finished. This oxygen, this one, I don't know if you can see. The oxygen on the left still needs to have 2 bonds. Then we also have a hydrogen that needs to give 1 to another oxygen. After which, this oxygen I don't know if this works. What? Yeah, no, because this oxygen needs a double bond, right? It needs to bond with hydrogen and then needs to bond with the other oxygen, which then has to take from the hydrogen. So it looks like that, but we can't do that. There's no way. This oxygen... Yeah, what? Okay, well then maybe then this oxygen doesn't bond with this oxygen. Maybe this oxygen gives its molecule to the second oxygen, like this. So it gives it to like this one over here, like this. So then this oxygen still has 1 more, which I guess it can use to bond to a hydrogen that is bonded to an oxygen, which is the one we see over here. But that's weird. Yeah, I don't think that's right. There is another one though. The hydrogen must give to this oxygen, which is bonded to a hydrogen. And this one that's bonded to a hydrogen cannot actually do anything else. So it kind of looks like that. But then now this oxygen with 1 bond can bond to this, but then this one has 2 bonds which it cannot bond with anything. Right, yeah. This is bad. This is also bad. Alright, but as you can see here... Yeah, no, this doesn't work. No, it doesn't work. I'm so confused as to how the molecule must look like for this. I'm just trying to draw random lines and see if it's possible to even make a molecule that works together. See, because now this one has 2 bonds, but these each are connected to each other by itself already. Oh, they're not. Oh, wait a minute. Wait a minute. They're not? How about this? Oh, okay, so it only makes the bond once it gets connected to the main thing. So right now it's not actually completely connected, meaning that we can actually separate these, you know, by means of doing something like so. I mean, obviously this is wrong so far. Because yeah, they have to give each other the thing. But okay, that's good to know, I guess. Oh, I can put an oxygen here. I can put this oxygen. Nope, no I cannot. Alright. Let's go back, See, I can do this. Oh, I can do this, I mean. Which then... No, but this oxygen has to first bond with this one. What am I making? This is really wrong. This is bad because we have 2... I seriously have no idea what molecule... I seriously have no idea what the structure is supposed to look like. Like which atom is supposed to bond with which one. I guess we just have to experiment and see what works. Again, I am looking at the same kind of deal. Like this. So what that means is that this oxygen must bond, the top oxygen must bond to both hydrogens. So how do I accomplish that? Can do that. And then I guess this? No. No, this is wrong already. I can do this though, which looks cool. But the problem is that I now actually need the oxygen to be all the way in the corner. So this is bad because then this oxygen bonds here, which is not good. We can't have that. We need the molecule to look like this. So maybe I need to go like... Oh, I don't know about this, man. This is already wrong. Is this the only way it works? Is my drawing the only way it would work? I mean, I think another way it would work is I can flip it to look like this instead. This also works. I can flip this. In fact, I can flip these in any way they like because they're both connected by the same bonds horizontally anyways. So I guess that now means that it doesn't have to be like this. Alright, which means that this actually is fine. Yeah, this is fine. However, we now need no, this is not fine. The H is wrong. The H that is supposed to be bonded here has to be this H. Weird. But sure. We can start by bonding to this oxygen first. So we start by first bonding to this oxygen. And now this oxygen is going to bond with the H, I think. Wait, no, this doesn't work. Naturally they bond normally. Like, oh, am I dumb? I am, okay. Yeah, this just bonds with this. Alright. Which makes these two that we need. Okay, good. Now this must bond to the normal hydrogen, I think. No, it must bond to the giving hydrogen, which must then bond to the what? Hold on. This oxygen must bond to the hydrogen, the normal hydrogen. Like this, as well as the normal hydrogen. Yeah, but that's wrong because these two need to touch each other. So firstly, these needs to be from the top. Like that, okay. This is bad. Again, needs to be from the top. This needs to attach to the top of this thing. We're close, but it's not even working. Alright. Let's try actually like this. Does this work? I mean, obviously not. We've tried that. If I did something like this first, I get an OH bond. Oh, I get something that seems to... I get this set here, I think. I think this is what I get. So now this H... No, I get it with this. Oh, that's not good. That's not good. That's not good. Wait, no, it doesn't work. Alright, think about this. What if this was the case? What if I had this oxygen with this hydrogen like this? then I would still need... I mean, I think that would work though, right? I can have this oxygen here, which is given to by this hydrogen. This hydrogen still has a normal bond though. Alright, let's just see what happens first though. This almost works, but it doesn't, because this oxygen bonds with this H. But we can't do that. Oh my. It almost works, but it's not even close. No, it's not even close. Yeah, see, and then these two need to bond to each other, but they can't. That's not... Huh? Alright, that's wrong then. We have to make it a cycling. Unless this one is the one that would double, but this needs to touch this, which I don't think it can. What the heck? Alright, I'm a bit delusional right now. I'm not even thinking about it. What have we built here? We have built this double oxygen, as well as this oxygen and this hydrogen. So this is what we've built so far. And now we first need this oxygen to be here. But we can't do that, can we? Oh, this works, but wait, that works. Oh my god, it works. I just found something that works, but now I can't reach the end. I found a set that works, but it can't reach the end. Oh my god, this is travesty. Holy crap! This doesn't reach the end. No, this doesn't even grab it. Oh my god, it almost works, but it doesn't work. I legitimately cannot believe this. Oh, it's so close. What can I change? I can't grab this first because this... You see, the entire point of this is to grab them separately. What if I had the H on the opposite side? Like this? What? No, that's even... what? Oh my gosh. That is some... That is something not right there. I don't know what I can change about this. Do I make a bigger loop around? Alright, at this point I'm not doing anything right. How long have I been playing this for? An hour, wow. Okay, this one's a long video. Mostly because I'm stuck on this one. I found something that almost works, but doesn't really quite. Is there something I'm supposed to know about that I don't? Oh my god, look at this. I basically won. I've basically won. It's like I've gotta grab this from the side though, but I can't do that. If I grab this from the side and then I grab this like that, this connects to here, which it can't, which it shouldn't. Unless I got this from the top and then got this on the side like that. Or maybe... Oh, damn. Okay, wow. We have a couple really almost there kind of strats. But none of them seem to work out. They all seem to be ever so wrong. Ever so slightly wrong. Actually, does this work? This should work, right? What? I want to move backwards now. How do I move backwards? I can't move backwards because if I move down, it gets blocked. See, if I can move backwards and down, then this thing, it would hit. This would be right. But no, because this hydrogen atom is blocking the way. This is bad. This is more correct. But then again... Why doesn't this work? Yeah, what is up with this? Why don't these two bond, by the way? I'm just wondering. Why don't they bond? Can they not? What? Alright, actually hold on, let me just quickly look at the original almost there solution. If I can find something that fixes this, that would be amazing. But right now, I just gotta memorize this and make sure if I ever find something, I get back to it. This is bad. It seems to work so well though. It seems to work so well. Alright. I guess the viewer can now watch another like 35 minutes or so of me just suffering through this before I finally find a solution that was basically what I did but with like one track difference. The ultimate pain. I don't think I can touch this. I keep thinking, can I? Can I? But I don't think so. See this? Yeah, all I need to do is move back. Oh, I can't. Yeah, I'm extending the track. I thought. No, you can't move back. Nope. So close though. I like this solution so much because it's also so close. Like, what the heck? If I somehow just merge them together, like, you know how I did. I have the basic geometry down. It has to look something like this. I just can't find the track that does it. Maybe I'll like post an update video if I really give up on this. Maybe it works if I do it like this for some reason. No, obviously I can't do this. Can't be too high, but I can do something like this. But then what? No, it just doesn't work. Yeah, because this needs to then connect with both this and this, but then these two have to connect to each other as well. Which, you know, obviously just doesn't make sense. Alright, how do I... Yeah, basically, you know. And then these two need to bond to each other as well, which doesn't work. In all cases, no, I can't do that. In all cases, these have to be separate. And I can't touch them because touching this oxygen at all means that they're just gonna have to bond to each other. Do I do something like this? No, right, I saw it doesn't work. Do I have to touch this first? It's close. I mean, for two reasons it's wrong. For, you know, two reasons. Yeah. Alright. I'm gonna try and pause the recording and see if I can get back when I solve something. Actually, you know what? Let's make good use of the hint system now. So this is what the molecule looks like, huh? Okay. Essentially what we have to do is kind of rotate this a bit. Maybe flip it around. Yeah, I think we do flip it around. This oxygen. Alright, let's see if I can draw a nicer version here. So it's this oxygen here, and this hydrogen here, this oxygen here, given to by this hydrogen here. This is what we want to look at. This is the molecule we're looking for, I think. I don't know if you can see it. This one on the right. What we're looking for with the oxygen here means that the normal oxygen, interesting, means that firstly this one must be above it. Okay, understandable. Good. Now this hydrogen must be on the right of it, like that. Good. Yeah, see this, it doesn't work, it breaks. It's close, but it breaks. This is exactly what I've drawn out here, but it breaks. Oh my gosh. Again, no, this doesn't work. Oh, what? Oh yeah, this is correct still. I don't know though. Does this just work? No, because they don't bond to each other. Yeah. The shape is right, but no, it's not. Nah, this is just wrong. Okay. At this point, I'm pretty sure what we know. I'm pretty sure what I've drawn down there is right. This is so close, but then like this is breaks, and then I can't do anything about it. Maybe again it is that oxygen is beside me and then hydrogen is on top. This breaks again as per usual. So what does this mean? Oh, what? Wait a minute. I'm sorry. Firstly, that's still wrong. That's right. Wow. Okay, what the heck? So when this goes up here, it bonds with one of these irregularly, bonds ionically. I don't know if I say it like that. The special electrons get bonded. And then here, I guess the normal electrons gets bonded. Oh, if the normal electron gets bonded here, then this normal electron cannot bond with this one because this normal electron already gets bonded. Oh. And then everything else works as per normal as what I've said. So that's the solution. Wow, okay, that was a lot to take in. Oh my god, insect pheromones are being made in the lab and sprayed on crops to drive pests so wild with lust that they're too confused to find a mate. Wow, okay. Isn't that like the same thing as like just bombing places with perfume? You just fill up the air with, you just fill up the room so much perfume that everyone gets gets with a sickeningly sweet smell. I guess it's similar in some way. Alright, we finished everything. Let's look at this one. Finished. Oh, is this the end? Oh, I've beaten the game. Right? Yeah. Yes, I have beaten the game. Wow. So there you have it. Soul Bond Express, the demo version. Yeah, it was pretty fun. A lot of cool logic despite this more being like a drawing game. I'm not gonna save the paint, right? So here you can see the map in its full glory. Yeah, have a good one.